Now here the question is, let A and be a sequence defined as A1 equals 3 by 2 and an+1 equals 2 minus 1 upon an. Now from here we can write A2 equals 2 minus 1 upon an, which is 2 by 3. So it will be simply 4 by 3. Now we'll prove two results. First we'll prove that the sequence is bounded below that is an, it is greater than 1. So this is our assertion Pn. Now we'll prove this result for n equals 1. We'll get A1. A1 is 3 by 2, which is greater than 1. That means P1 is true. Now second step is, let Pk be true. It means Ak, it will be greater than 1. If Ak is greater than 1, 1 upon Ak will be less than 1, and minus 1 upon Ak, it will be greater than minus 1. Now we'll add 2 to it. Now this is nothing but this is Ak plus 1. So from here we can say Ak plus 1 will be greater than 1. So this sequence is bounded below and an is greater than 1. Now in the second part we'll prove that this sequence is monotonic decreasing sequence. That is an plus 1 will be less than an. Now here this is our Pn. Now for n equals 1 we'll get A2, and A2 is 4 by 3, which is less than 3 by 2, and that is A1. So that means P1 is true. Now second step, let Pk be true. Now if Pk is true, it means Ak plus 1 will be less than Ak. Now if we take a reciprocal, we can write 1 upon Ak plus 1 will be greater than 1 upon Ak. Now we multiply with the minus sign and then add 2. We can write 2 minus 1 upon Ak plus 1 will be less than 2 minus 1 upon Ak. This is nothing but this is Ak plus 2, and it is less than Ak plus 1. That means P k plus 1 is true. So from mathematical induction we can say that this sequence is monotone decreasing sequence. So the sequence is bounded below and it is monotone decreasing. Then we can say that this sequence, it is a convergent sequence. Now we need to find limit of convergence. Now suppose the limit is L. We can write L equals 2 minus 1 by L. Now this is L square minus 2L plus 1 equals 0. That is the value of L is 1. So this sequence converges and it converges to 1.